Hello everyone. Today we're going to explain the Russian peasant multiplication algorithm. This ancient algorithm provides an efficient method for multiplying two numbers. It is an algorithmic method for multiplying two numbers by halving one of the numbers and doubling the other until the first number becomes 1, then summing the values of the second number corresponding to the halved values of the first number. So, how exactly does this algorithm work? Let's walk through a step-by-step example to understand the process. For example, let's say we want to multiply 174 and 54. First, let's create two columns, one for multiplying, one for dividing. We multiply the first number, then divide the second one. Then again, we multiply the result of first number and divide the result of second number. We keep repeating this process until the dividing column reaches 1. After that, we go through the dividing column and look for the odd numbers. 54 is not an odd number, so we are canceling this row out. 27 is an odd number, so we are going to add 348 to the total sum. We keep going on and calculating the sum until we finish the column and we end up with a total of 9,369. And that's how the algorithm works. Secondly, we are moving on to the code implementation. Start with initializing a variable sum and set it to 0. Write a while loop that stops when a value reaches 0. If a is an odd number, we add the value b to the sum. Then we divide a by 2 and multiply b by 2 and don't forget to return the sum. Let's trace this code assuming a is 13 and b is 45. A is an odd number, so we are going to add 45 to the sum. Divide a, multiply b, then repeat. In the end, we get a value of 585, which is the result of multiplying 13 times 45. This code can also be implemented recursively. In the first case, if a is even, we go on by halving and doubling. If a reached 1, then we end. Else, if a is odd, we half and double and add b to the sum. Now, let's analyze this code. We are going to enter variable a as n. The modulus operation is the most repeated operation in the code. Then we add the recursive, which halves the n. And this is going to be our base case that we are going to use later in the analysis. First, we are taking this n and turn it into n over 2. After that, substitute in the equation. Repeat this process again on the resulted equation. If you noticed, repeating this process results in seeing a pattern that we can generalize, which is t of n is equal to t of n over 2 to the power of k plus 1. Now we want to solve for n over 2 to the power of k and make it equal to 1 in order to reach the base case. After solving for k, we get that n is equal to 1 when k is equal to 0. Therefore, we get the time complexity of big O of log n. That's it for this video. I hope you found this algorithm both interesting and valuable. Thank you for listening.